Hello everyone, and today we're going to present for you a physics podcast. And our podcast is about Christiaan Huygens. He was a physicist, mathematician, astronomer, and orologist. And we have here some guests to share with us their knowledge. Hello, Gus.
Hello everyone, I am Gustavo and I am very happy for participation in this podcast.
Hello, Arthur. How are you?
Good afternoon, everyone. Thank you very much for having this participation.
And we have here too João. Hello.
Hello, Nathan. What's up, everyone? I want to say thank you for this expression invited for this podcast. It's going to be very exciting.
I thank you for your participation. It's a pleasure to be here to share your knowledge. My name is Nathan, and now starts our podcast. To start here, we need to know who was Christiaan Huygens. I don't know who was Christiaan Huygens. To help us here, we have Arthur. Hello, Arthur. Who was
Hello,
Christiaan Huygens?
hello. Okay, I will talk about your MBO. Let's go. Christian Huygens, as Nathan said, was a Dutch mathematician, physicist, and astronomer, born in the Hague, Holland, on the 14th of April, 1607. He was the second of the four children of the poet and diplomat Constantine Huygens (1596,687). He was a man of broad culture who also dedicated himself to the sciences. From his father, Huygens received his first instructions in mathematics and mechanics at the age of 13, and from an early age aroused interest and skill in both. He became the most prestigious international scientist of his time. In childhood, he met renowned intellectuals such as René Descartes and received an education in mathematics and physics at the University of Leiden, where he studied with Franz van Schutten, a former student of Descartes. At the age of 16, Huygens entered Leiden University to study law, and soon after was transferred to Breda, where his father ran the new university graduation 2 years later in law. In both places he continued his studies in mathematics, but only after graduating did he turn his attention to the study of the physical and mathematical sciences. At the age of 17, he communicated his first mathematical discovery to Mersenne, who introduced him to the works of Archimedes, and soon after he was already in correspondence with the most important scientists in Europe. At 1651, at 21 years of age, Huygens publishes his first works of mathematics, the most important being on the squares of the conic sections. In 1654, he made the best approximation achieved until then of the area of the circle. 2 years later, he sent Van Schooten his work on the calculation of probability and applied the ratiocines in Lodo Alea. Christiaan Huygens was seriously ill for the last 5 years of his life. Huygens died in his hometown, The Hague, on July 80, 1695.
Oh my god, how interesting! Since childhood, he was a very intelligent person and dedicated to his studies. I admire him a lot. He was very smart.
Yes, I think about that too. And one funny thing, he kind of studied a lot the philosophers. Like his father was on poetry, so he had that influence, and he's one person who can see both words in the same problem. Like you can see through his theories how he can puts and takes some of the arguments from the philosopher's words into the science words. This is a very interesting thing.
Yes, yes, it's very nice.
Now I live with you, João. What can you tell us about your ideas and inventions? Oh, no, no, sorry. About Christian Huygens' ideas and inventions.
Well, he invented the pendulum clock in 1656, and he created the wave theory of the light in 1678, which led him to perfect the telescope lenses by correcting a Galileo error. And also he discovered the centrifugal force and the true shape of Saturn's rings, as well the moon of Saturn, the Titan. He had one principle called Huygens' principle, which says every point on a wave front is the center of a new wave, allowed to explain the reflection and refraction of the light. So based on that, we can say that he, the motive because he was against Newton. It's kind of he believed that the waves, the light, wasn't like a real thing, a material thing, right? It was like wave, like radiation or radio waves. And Newton proposed that the light was like a group of particles, and that's the principal divergence of between the two ideas. Another thing about him he is that his efforts in mathematics, including his work on squaring the circle, when he came to physics, in addition to his landmarks Huygens principle, he extensively researched free fall, pendulum movement, and the pendulum clock. This means that we are talking about like the 17th century, right? So he wasn't at the same time research things like Newton. They research about the same things, but in some cases, like the light, they have divergent thoughts. And one curious thing about that is because his thoughts they influenced the famous physicist Albert Einstein in one of his first theories when he says and he can explain why the light is a wave. Huygens also improved marine clocks, which proved to be very useful in finding the positions of ships at sea.
Incredible, really incredible. He had a great influence on the current physicists, like the great Albert Einstein. And although he was a very well known, he had to have a lot of courage to present a theory that diverged from Newton's just at the time he was on the rise. I'm starting to become a fan of this guy. Really, a really fan of this guy. Now, Gustavo will talk a little more about the main idea contrary to Newton's thoughts.
Alright, light was a topic widely discussed by philosophers of the past. Empedocles, with his theories of the four elements, thought that light was made up of the elements of fire. Aristotle thinks that it was a vibrator of ether, that it was a mysterious substance, and that it would vibrate with speed of light. Euclid thought that the light came out of the eyes and went towards the body we wanted to observe. Advancing into the 17th century, we have Newton and Huygens talking about the composition of light. Newton believed that light was made of particles and that his reflection was the elastic collision of these particles with a mirror, and Huygens believed that it was made of waves and that it spread through the reflection of a wave. Newton believed that light was faster in water than in the air, and Huygens was the opposite. Shortly thereafter, a lot of experiments were carried out to find who was right, and in the end it was discovered that Huygens' ideas explained reflection, diffraction, diffraction, and interference better than Newton.
And this was the podcast about the plot of Huygens and his life. I would like to thank you all the guests.
Thank you, it was my pleasure.
Okay, thank you very much for participating, and I hope you have more peaceful podcast.
Thank you, Nathan. It was my pleasure to be here today talking about this phenomenal man with you guys.
And I would like to thank you all the viewers of our physical podcast. Bye bye and see you at the next time.